All right, I think we're ready to go. So we're finishing 10.1 today. We'll start 10.2 on Monday. That'll be the law of cosines. If you're good with 10.1, 10.2 should be even easier, okay? Most people find the law of cosines the easier of the two laws to use, and then we'll start using both of them together, which again is not usually a struggle for a lot of people. Chapter 10 is really a lot of hodgepodge stuff right here, okay? Just going to be bouncing back and forth between a lot of different applications. This is kind of like the epilogue of the class. Like, okay, we did all the crazy stuff. Now let's just, hey, here's some cool stuff. Here's some cool stuff. Here's some cool stuff. If you thought 9.5 was really easy, that's good to hear too. Yeah. That's awesome. 9.5 becomes a lot easier, I think, if you're strong with algebra. All right, here we go. We got 3 example problems to do today. Example 3. Solve the triangle. Good, because that's the goal, Alex. The goal is that like the homework should be quite hard. Some of the problems should be easy, but some of the problems should be quite hard. And the quizzes should be a little bit easier than that. And the exam should be a little bit easier than that. The exams are not supposed to, like, you know, make you go bald with stress or whatever. They're really just to check, hey, you actually know this stuff. But the homeworks and quizzes are supposed to be harder. And the homework's supposed to be kind of the hardest kinds of problems there are. So that's good to hear that that was the case for you. All right, so we're solving some triangle that looks like this, maybe. Figure not drawn to scale, alpha, beta, gamma. A is unknown. B is 9. And C is 12. And we're supposed to solve this, knowing that gamma is 85 degrees. So remember the law of sines, right? The law of sines said that sine of alpha over A equals sine of beta over B equals sine of gamma over C. Side note, in your formula sheet, chapter 10 formula sheet on Canvas, these are capital A, capital B, capital C. It doesn't matter what you call the angles. Here it is. So when we're using the law of sines, we just choose something that, a pair that we know, and a pair that we only know one. A pair that we know the whole thing of, and a pair that we only know one of, and then we set up a ratio. So we need to find an angle on an opposite side that we know. Well, we only know one angle, and we know it's its opposite side. So we set up sine of 85 degrees divided by its opposite side, 12. And then we can just choose, okay, now we need to find something we know and something we don't know. Well, we know this 9, and we don't know its angle. We'll choose that, sine of beta over 9. And we just solve. So multiply both sides by 9. You're going to get sine of beta equals sine of 85 degrees divided by 12 times 9. And what's that equal to, approximately? If we're trying to solve this, it's a good idea to get an idea of what it looks like. And we sine of 85 degrees divided by 12 times 9. That's about 0.7471. Okay, so there is going to be a solution. And the question is there one solution that makes sense here? Are there 2 solutions that make sense here? Because as we did in 9.5, there's infinitely many solutions to this equation. The question is, how many make sense for this triangle? Okay, so let's use inverse sine of 0.7471. What we're going to get right there is 48.3 degrees about. So this answer makes sense. And this first answer will always make sense. The question is, does the other answer in the second quadrant, does the beta prime in quadrant 2 also make sense? Because if it does, then we're going to have 2 answers. So again, what's the angle in the second quadrant? In the first quadrant, it's about 50 degrees. Wait, why does this seem so familiar? Have we done this problem? I don't think we've done this problem, but it seems super familiar. Well, let's keep going. So if this is about that 50 degrees, there's another answer in the same second quadrant with the same reference angle. 48.3 degrees. The question is, what is the actual angle in the second quadrant? We take 180 degrees minus the reference angle. So beta prime would be 180 degrees minus that reference angle of 48.3398. And that's going to equal 131. All right, we have not done this one. 0.6602 degrees. So does this make sense? Does this make sense as a second answer, a second solution for the triangle? Could beta be that big? And there's two reasons why the answer is no. That beta prime cannot. This is not an okay angle. Two reasons why. One, notice that if we take gamma plus beta prime, that's 85 degrees plus 131. That's more than 180. So no, it does not make sense. Only one solution here. Another way that you could see that beta prime is not okay for this triangle is look. Beta prime is bigger than gamma. 131 is a bigger angle than 85, but its opposite side is smaller than the opposite side of gamma. So that's impossible. So this is a good case for the side-side angle triangle, all right, when there's only one solution. So we could essentially cross all this stuff out if we want. We don't need it. I'm not going to cross it out because I'm going to show these notes, post these notes to Discord afterwards. It'd be kind of silly if I crossed out my notes. But essentially, the answer to all of this, again, is just no. So we keep on solving. We found beta to be about 48.3 degrees. Well, now we can find alpha. We know two angles. We can find the third one. So alpha is just what's left over because all the angles together need to add up to 180 degrees. The alpha is going to be 180 minus 85 minus 48.3398. You're going to get that alpha is approximately 46.6602 degrees. So about 46.7. We fill that in. Great. We have all three angles. We have two of the sides. All that's left is to find that last side, A. So we set up the law of sines just like we did, but now we choose the other pair for the right-hand side. We get the sine of 85 degrees divided by 12, just like the first time we set up the law of sines, equals the sine of alpha. We use the other pair this time, which is 46.6602 degrees, divided by A, which we do not know. And now we solve this. And again, it's good practice to use as many decimal points as you can. I'll be using 4 decimal points for everything, but if I were not teaching, I'd be using more because I don't like rounding errors, but I'm not going to ask you to do more than 4. And we just solve this. So we can cross multiply. Again, I trust you guys know how to solve this, but if you don't, feel free to ask. So what we're going to get is that A is going to be the multiply the A to both sides, multiply by the reciprocal. 12 divided by sine of 85 degrees times sine of that 46.6602 degrees. And that'll give us A is approximately 8.7609, or about 8.8. So one of the biggest things I want you to take away from this section is once you've solved your triangle, get in the habit of checking. Check this answer. Okay, remember, the biggest angle should be opposite the biggest side. The biggest angle is 85 degrees. It's opposite 12. Good, 12 is the biggest side. Smallest angle, just by a little bit, is 46.7 degrees. Smallest side, also just by a little bit, is that opposite side of 8.8. Okay. It's just one of the best ways that you can quickly check, did I make a big mistake? So again, these problems are long, right? This takes a whole page, and they're even longer. They're even longer when you have two solutions. So watch out for the situations in the homework with two solutions. All right. If there are any questions, go ahead and ask them. Otherwise, I'm going to go on to the next example problem. And you're going to like the next example problem, okay? I said the two situation case is the worst. The one situation case is average. But there's another case that's really nice. We're going to see that in example 4, I believe. So, solve. The triangle where one side has length 4, opposite, just showing another way you could ask this question, opposite an angle of 50 degrees, and a second side has length 10. So a lot of times you're not going to be given a picture, which makes a lot of sense in this section, because the picture can't always be accurate. Sometimes there are two pictures that are correct. Sometimes there are no pictures that are correct. So a lot of times they will give you a problem in a way that doesn't have a picture. So I like drawing a picture just as a little visual aid. It doesn't have to be accurate. A lot of times it won't be accurate, but just, I don't know, a lot of times it's just like drawing a triangle. And we can just name them however we want. A, B, C, alpha, beta, gamma. We could name them Joe, Kelly, and Charlie. I don't know. Okay. You can name your angles whatever you want. And then you can name the opposite sides as well. So one side is length 4. Say that's over here. I don't know. And it has to be opposite an angle of 50 degrees. So this is 50 degrees right here. And another side has length 10. So we could make this 10 or this 10. It doesn't matter. I just think it's a lot easier to solve these when you have some sort of visual aid, when you can see it. Okay. So just like before, we need to use the law of sines. So we find a pair that we know, 50 and 4. A sine of 50 degrees divided by 4 equals a pair that we know half of, so 10 and gamma. Sine of 10 degrees. Whoa, that's not it. 10 is the side length. Sine of gamma divided by 10. Multiply both sides by 10. You get sine of gamma equals the sine of 50 degrees divided by 4 times 10. Or that sine of gamma, we approximate that right-hand side. What do we get? We get about 1.9151. And this is the best situation. This is what you want to see on your homework. This is what you want to see on your quiz. If you are actually solving a real life problem, it might be bad. Because what situation is it? What do we have here? What's going on? What does this tell us? Tells us that there's no answer. If we tried to take inverse sine of both sides here, we'd get domain error. No solution. Sine is always between -1 and 1. There's no solution. There's no value of gamma that makes this true. And we're done. That's it. That's the whole problem. We don't have to find anything else because there is no solution to this triangle. And sort of what's happening here, right, is that this side up here is so long that the only way we could have gamma big enough to make this big is to go over 180 degrees in our triangle, which is impossible. Okay. So that's that. Sure. So essentially, as soon as we get here, we know there's no solution. If you didn't see this though right away, you could solve for gamma, right? You'd say gamma is going to be the inverse sine of 1.9151, and you'll get a domain error. And that's going to tell you that there's no solution to this equation. Additionally, the range of sine is -1 to 1. So the output can never be outside of -1 to 1. Essentially, right? We know the graph of sine back to chapter 8. The graph of sine always oscillates between -1 and 1. So essentially, another way we're asking this, kind of to address antonymity's question, is saying, okay, when is this function going to cross this dotted line or this dash line? When is this function going to cross this dash line? And the answer is never, right? It's periodic. It's just going to keep waving and waving and waving, but it's never going to get this big. Okay. So if you remember the range of sine being -1 to 1, then it works out like this. But even if you forget the range, even if you forget this, when you type this into your calculator to find out what gamma has to be, it'll tell you nothing. It'll say, hey, we got a problem here. Okay, good questions. Any other questions before we go on? Because we only have one more example problem to do. And then if people have homework questions that they want to go over, I can. Otherwise, we'll just be done early today because we're just finishing this section. So next up, we're going to talk about area, and we can use the law of sines to make area problems a little straightforward. If you remember at the beginning of class what we did, at the beginning of class, we kind of showed where the law of sines came from by solving some triangle and using a system of equations on that h value, that height, that dash line right there. And so essentially, we can also just do the same thing with area. Because area, right, is 1/2 base times height. So we just replace the height with what it is in trig functions, right? So here height with trig is c times the sine of alpha. You don't need the law of sines to do this. You could find this all out on your own. But there is a formula, and it's given you in your chapter 10 formula sheet, which you will have available for all your chapter 10 quizzes and homework. This formula right here. This will be given to you. And essentially, all that is, again, I don't think anyone's going to struggle with these problems, but I do want to explain it just in case it is harder than I expect. You just use the formula and you can find the area of non-right triangles pretty quickly. All right. So let's just do one of those. So again, area is what we're talking about next. And we have 3 formulas you can use depending on what you have. Area is 1/2 BC sine alpha, or 1/2 AC sine beta, or 1/2, what one's left? AB sine gamma. All right, so notice that you essentially have A, B, C in every single one of these formulas. It's just one of the A's is an alpha, or the B is a beta, or the C is a gamma. All right, and you can just use whichever formula here has the stuff that you have. So for example, 5, for example, we don't even need to draw a picture, right? Find the area of a triangle with sides A equals 90, B equals 52, and angle gamma equals 102 degrees. If you want to draw a triangle, go for it. Okay? If you don't want to use the law of sines at all, that's fine too. Or you could say, well, we have A, we have B, and we have gamma. use this formula right here. 1/2 AB sine gamma. And you just plug it in. 1/2 A, which is 90, times B, which is 52, times the sine of gamma, which is 102 degrees, and that's all there is to it. Type that in your calculator, get an approximation. You get the area is approximately 2288.8654 units squared. They didn't tell us what units we're using, so. And that's area problems. Just use the formula that you'll have. And that's the section. Okay? 20 minutes. We could start the next section, but we don't need to. We have plenty of time. For attendance, I'll ask the attendance question now. But for the rest of class, if you don't have any homework questions, then you can feel free to head out. But if you do have homework questions about anything or questions about the quiz, now's a good time to ask them. Okay? For the attendance question today, send me the name of a flower. I like flowers. Send me the name of a kind of flower for your attendance points today. Okay? And let me know if you have homework questions. We can go over those now. Or if you just if you're struggling with this section, or if you just want to see me do more of these problems, that can be good too. Especially maybe the 2 answer cases of the triangles, just let me know. I'll wait about a minute for questions, and if there are no questions, then I'll just leave. Don't forget to grade your quiz. Yeah, I'm grading quizzes today. There's always a reminder. It tells me when I haven't graded a quiz. It's not really possible to forget. I think there are 2 quizzes this class I need to grade, and then all the quizzes for my other class. Here we go. We have a nice little flower right here. Coffee cake sounds so good. Cleaning up sounds less good. It looks like there are no homework questions, but if you do get some over the weekend, just message me on Discord. Hope all of you have a good day. Have a good weekend. This is a nice way to go into the weekend, I'd say. So, yeah, take it easy. Bye-bye.